everyone. This is topic 14 of your syllabus. In the previous video, we tackled what organic refers to and a general introduction to how we can name organic compounds. Now, this video is about the second chunk of this topic, which is all about the fuels. Alright, so what do we mean by fuels? A fuel is basically any substance when burnt releases energy. So this is an exothermic reaction. And we said before that in chemistry, burning can also be called combustion reaction. This combustion reaction can either be complete combustion if the oxygen supply was sufficient, so the products would be carbon dioxide and water, but in case of insufficient supply of oxygen, incomplete combustion would occur, which is actually a problem because a toxic product is going to be formed, which is carbon monoxide. What about fossil fuels? Fossil fuels basically refers to fuels that have been formed from the remains of ancient animals and plants millions of years ago. These include coal, crude oil, and natural gas. You should also know that crude oil can also be referred to as petroleum and that the main component of natural gas is methane. This is a kind reminder for the structure of methane. So remember CH4, this is the molecular formula as it includes the exact number of atoms inside my molecule, whereas the structural formula shows the structure as the name suggests or the way the atoms are bonded together. So it belongs to the homologous series alkanes. One of the fossil fuels we've referred to is crude oil or petroleum. Petroleum is in fact a mixture of many hydrocarbons. So as a mixture, it isn't really very useful. However, when splitting it into its individual components or fractions, we can basically make a lot of applications or a lot of uses for this fraction. What technique is suitable in such case? It's the fractional distillation, which we've already tackled in the second topic or experimental techniques. Fraction distillation, as a quick reminder, this is used to separate a mixture of miscible liquids that have different boiling points. So the different boiling points is my key word here. Another commonly asked definition in papers 3 or 4, according to your core or extended, is fraction. What do we mean by fraction? Fraction is basically a group of hydrocarbons or molecules that have a similar number of carbon atoms and a similar molecular mass with a defined boiling point range. That's why they're going to distill off at the same place during the fractional distillation. So this is one of the industrial processes where crude oil enters the fractionating column from the bottom left corner. Crude oil or petroleum, of course. This is preheated. If you remember, distillation is basically two steps. Boiling happens at first, followed by condensation. So if I have preheated crude oil, they will start to separate into its different fractions according to the boiling point ranges. What do I need to know from this slide? Firstly, you should know what exactly happens, or you should be able to describe the process of fractional distillation. So what happens is if you realize the temperature differences, the fractionating column is hottest at the bottom and coolest at the top. So as I said, crude oil will enter preheated, the vapors will start rising, and then they will distill off or separate at different areas of the fractionating column according to the boiling points. The ones with the least boiling point will separate first or at the top of the column. So for instance, refinery gas, if I compare it to bitumen, refinery gas has a much lower boiling point. It boils at 20 degrees Celsius, so to separate as a gas at the top. In the middle of the column, they separate as liquids, and in the very bottom, they separate as solids. So these are the different fractions. I should be able to know the uses of each fraction. So for instance, refinery gas, this is the bottled gas that I use for home cooking and heating. Petrol, which is also known as gasoline, is used for the cars. Remember, you need to know both synonyms, so petrol and gasoline. Naphtha is used in the chemical industry to make chemicals. Kerosene, or also known as paraffin, is a jet fuel used in planes. It's also used for lighting and heating. Diesel is used in diesel engines, can also be known as gas oil. Lubricating oil is either used as a lubricant in waxes and polishes. Fuel oil is used in ships or central heating. And finally, bitumen or asphalt, it's used in roads or roofing. Now let's dig deeper into this column. Again, I'm going to compare between refinery gas and bitumen. Now, in terms of the molecular size, refinery gas is actually a smaller molecule. Now, since it's smaller, so the number of bonds between the atoms within the molecule are much less, so they require less energy to break these bonds, hence the lower boiling point. Now, adding on to its properties, it's much easier to light and ignite compared to the ones below it, and it is runny instead of viscous. Those at the top tend to be more runny liquids, they easily flow, whereas the ones at the bottom are more thick or viscous like the texture of honey. So this is basically a summary of what we've said so far. In recap, I need to be familiar with all the uses. I should also know the order of their separation. So you should know that refinery gas is separated before gasoline, before naphtha, and so on. So the order is very crucial. Going up the column, they're getting smaller in size with less carbon atoms, hence smaller molecular masses or lower molecular masses. Boiling points and viscosity are both lower, but they tend to ignite easily. They're more flammable and more volatile. That's why something like in the benzene or the gasoline for the cars at the gas stations, you get to smell them very easily since they are easily volatile compared to the ones at the bottom. This is the end of this video. See you at the next chunk.